Okay, let's get started with our next set of notes here. To begin, what I'd like you to do is factor the following and find their roots. So you have 3 problems, pause the video, give those a try. Okay, when we're factoring where x value is equal to, or a value is 1, we look for numbers that multiply to c, so multiply to 8, and add to b, so add to -6. Those numbers in this case would be -4 and -2. From there, to find the roots, you set each factor equal to 0, solve for x. So we get x equals 4 and x equals 2. Okay, if you did not do that, if you did not get that correct, I recommend pausing this real quick, trying those other 2 again. Okay. Again, our a value is 1, so we look for numbers that multiply to c and add to b. So multiply to -36 and add to 0, because there's no x terms. So that'd be positive and -6, to which our root should be -6 and 6. From there, we're looking for numbers that multiply to c and add to b, multiply to 16, add to 10. Those are 8 and 2. Our roots are -8 and -2. Okay. All right, the focus for today is working through describing characteristics of quadratic functions given their equation. So what we're going to do is we're going to first talk about how to find some of these things. So the first thing is type of function. So the way we determine our type of function usually is by looking at the highest exponent, or what's the degree of the function. When you have an x squared type function, when you have that squared, that means we have a quadratic function. The way we determine our x-intercepts from a function is you start by factoring, and then you set the factors equal to 0. So what we did up top, x-intercepts, same thing as roots. X-intercepts, same as roots, so that's essentially what we do to find our x-intercepts. So like in the case of this problem where we have x squared plus 12x plus 20, we look to factor that out. So numbers that multiply to 20 and add to 12, which would be 10 and 2. Set each factor equal to 0. Solve for x, we get x equals -10 and x equals -2. Okay. Remember, axis of symmetry, that's the line that cuts directly in half of your parabola. The way we determine that from an equation is our axis of symmetry is always x equals -b over 2a. So if we want to do that, and that a, b, and c, same a, b, and c they've been, so our b value is 12, our a value would be 1. So our answer would be here negative b value of 12 over 2 times 1. So negative 12 over 2, which is -6. So x equals -6 would be our axis of symmetry. The way we find our vertex, remember the vertex and axis of symmetry have that same x value. So the x value of our vertex is always going to be -b over 2a. The way we determine the y value is by plugging that in. So we can call that as f of -b over 2a. This just means you plug in -b over 2a in for x. So like in this problem, we have -6 would be our x value for the vertex. To find our y value, you take -6 and you plug it into the original function. -6 squared is 36. 12 times -6 is -72. 36 minus 72 is -36 plus 20 is -16. So that means we have a y value of -16, so that would be our vertex. Okay. The last thing we want to touch on here is factored form and vertex form. So factored form essentially just means, so you take your original function and you factor it out into what multiplies to c and adds to b. So essentially what we already did to find our x-intercepts. So in factored form, it'd be x plus 10 times x plus 2. Vertex form, remember, is written as y equals, or f of x equals, a times x minus h squared plus k, where h and k is the vertex. So our vertex here was -6 and -16. Our a value is that same a value from up top, so in this case it's still just 1. So it'd be x minus h, or minus -6, which would give us a plus 6, plus k, or plus -16, so minus 16 in this case. Okay. All right, so let's put that all together here for a couple of problems. So for the one on the left here, we have y equals x squared plus 6x minus 16. So let's start first by identifying the type. So we determine the type by the highest exponent. If it has an exponent of 2, it's a quadratic function. And little hint, it's always going to be quadratic for this unit, since this unit is always all about quadratic functions. Yeah. Axis of symmetry is x equals -b over 2a. So to find our axis of symmetry, let's plug in x equals -b is 6 over 2 times a is 1. So we'd have x equals -6 over 2, which is just -3. So x equals -3 is our axis of symmetry. And you have to have that x equals. Don't just write -3, that's wrong. It's got to have the x equals part. Our vertex, remember? So to find your vertex, you take -b over 2a. So what's from your axis of symmetry, which in this case was -3, and then you plug that into the original function. So we're going to plug -3 back in to the original. So -3 squared is 9. 6 times -3 is -18. 9 minus 18 is -9. Minus 16 is -25. So we get -25 for y. To find our x-intercepts, or our roots, we factor and set the factors equal to 0. So let's take our function and factor it. So we're taking x squared plus 6x minus 16. We look for what multiplies to -16 and adds to 6, which in this case would be +8 and -2. And ding, 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 that's actually our factored form. So factoring out actually helps there. And then we set each factor equal to 0. Solve for x. We get x equals -8 and x equals 2. So our x-intercepts would be x equals -8 and x equals 2. Last thing we need to do is write in vertex form, which is y equals a times x minus h squared plus k. Our a value is whatever's with x squared, which in this case is just 1. So we don't need to have anything there. Our h value, remember, comes from our vertex. hk is our vertex. So our vertex is -3, -25. So x minus h, or minus -3, that changes to plus. So x plus 3 squared minus 25, because it's plus k, and k is -25. And those would be our final answers. Okay. All right, why don't you pause the video, looking over your notes, and try the second one on your own. Okay, we're back. This is a quadratic function since its x squared is the highest degree. The equation of the axis of symmetry, so remember x equals -b, so b is -4 here, over 2 times a, which is 1. -4 times -4 is positive. 2 times 1 is 2. So we get 2, or x equals 2 for our equation of axis of symmetry. That axis of symmetry has the same value for our vertex. So to figure out our y value now, we plug in 2 for x into the equation, solve for y. 2 squared is 4. 4 minus 8 is negative 4. Minus 12 is negative 16. So we get y for negative 16. To find our x-intercepts, we need to factor. So we'll take x squared minus 4x minus 12. Set it equal to 0 and factor into what multiplies to c and adds to b. Multiplies to negative 12, adds to negative 4, which would be negative 6 and 2. Set those factors equal to 0. And we get x equals 6 and x equals negative 2. So in the previous problem, we wrote those as x equals. You could also write your x-intercepts as points if you want, being 6, 0 and negative 2, 0, because x-intercepts are on the x-axis. Our factored form, we already did. It's just your step of factoring, which this is just another way of writing your function, so you gotta have that y. And then vertex form, y equals a, which is 1, times x minus h, which is here, hk, our vertex, h squared plus k, which is negative 16. It's plus minus 16, or you could write just minus 16 there as well. Okay, and that is it. All right, we do have a couple other things we want to identify. These last few pieces are on, at least I would say, the easier side. They're at least quick to identify. So what we have here, something new. We have 3 functions, and I've shown the graph for each of those functions. Wait a minute. This one's wrong. Okay. Let's ignore this one. That's my bad. So we have 2 functions here. I'm wondering, what do you notice about the y-intercept as it relates to the equation? So pause the video, quick think about it. Okay, so we're back. So the y-intercept, you may notice, it's 2 here, it's negative 2 here. The y-intercept is the c value. So all you need to do to find the y-intercept is you just look at the equation, and it's the c value. So like if we wanted to identify the y-intercept for a few functions, so y equals 5x squared minus 6x plus 2. Our y-intercept would be 2. Here, 6x squared plus 2x plus 1, well, whatever number's on the end, y-intercept is 1. Here, y equals negative x squared plus 4x, but there's nothing there. Oops. If there's nothing there, we can think of it as plus 0, so our y-intercept would be 0. Not too bad. The last 2 things to look at here, and then we're just going to tie it all together, has to do with directionality and maximum and minimum. So as we look at these 2 functions, you may notice, let's first look at the equations here. These equations are the exact same except for our a value is 2 here, and it is negative 2 there. And as we look at the graph, with a positive a value, it opens up. With a negative, it opens down. So we can conclude that when our a value is positive, the graph will open up. And when our a value is negative, like here, the graph will open down. In addition to that, whenever your graph opens up like this, whenever you have a quadratic that opens up, your vertex is always going to be a minimum. Whenever it opens down like this, your vertex is always going to be a maximum. And that will always be the case no matter what quadratic function you have. All right, let's finish it up. Let's apply all these different characteristics. Pause the video, give it all a try on your own, take your time with this, and then we'll talk through it together. Okay, we're back. This is a quadratic function, since it's x squared. We're looking for roots or x-intercepts, so that means we want to factor. So look for what multiplies to c and adds to b. Should be 5 and 4. Set those factors equal to 0. Solve for x, we get negative 5 and negative 4. Y-intercept, that's just the c value, is 20, or y equals 20. Line of symmetry is negative b over 2a. So x equals negative 9 over 2 times a, which is 1. So negative 9 over 2. Or you could write that as negative 4.5. So x equals negative 9 over 2. To find the vertex, remember the x value is the same as your line of symmetry. To get the y value, you just have to plug that in for x into your equation. So I'm just taking the equation, substituting negative 9 over 2 for x. So here we get 81 over 4 plus negative 81 over 2 plus 20. To combine fractions, we want to have the same denominator. So let's multiply the top and bottom by 2 here to get negative 162 over 4. Multiply this by 4 over 4 to get 80 over 4. And that'll simplify down to negative 1/4. So that'll be our y value. Directionality, our a value is positive. When a is positive, it opens up. When it opens up, we have a minimum as our vertex. In factored form, that's already written up here, we have x plus 5, x plus 4, so it's just the form after factoring, right there. Vertex form, remember, y equals a times x minus h squared plus k. Our a value is 1, so we just have x, no a there. Our h is negative 9 over 2, so x minus negative 9 would be plus positive 9 over 2. And minus 1/4. And there we have it. That is it.